Welcome back. You're still watching World Insight, and I'm Tian Wei. China and the U.S. are in competition, quote unquote, not only with trade, but with technological innovation and intellectual property, some say. The White House took retaliatory trade action against China, ignoring China's efforts to improve intellectual property protection. In tonight's interview, a prominent scientist shared his insight on intellectual property rights and innovation. He is Peidong, a professor of chemistry and material science. He is well known for his work in nanostructure and characterization and working on how humans could live in Mars. Peidong earned a PhD in chemistry at Harvard University. In 2010, he was ranked as a top material scientist among the top 10 chemists of the decade. And also, currently, he is a professor at the University of California, Berkeley. He thinks China could adopt a mechanism that balanced support for both basic and applied research. Take a look. If we could just compare a little bit about what is going on in China and the United States, which both are places you're rather familiar with, you do see a difference. Is there so-called a better strategy or a better practice? Or there could be just different ways of doing it?
Not necessarily. I think it's just China is at current stage. If we look at United States, like my research group is typically at this stage probably 50% is supported by government. Then another 50% is from the sort of the foundation, from industry.
Yes.
I do have a bigger industry center at Berkeley too.
Right.
So
when you say coming from the government, explain please.
The government, like the Department of Energy, NASA, I mean, that's a typical sort of funding agency in US, right? It's just like in China, that's the National Science Foundation, right? Those sort of government funding agency.
Right.
We do have a very healthy sort of portfolio in terms of the research funding. Let's say the government funding, we do have two pools too. One is basic research, one is applied research. For example, in the Department of Energy, we have basic energy science division. That's really for sort of blue sky type research. Okay, no question asked, you just give you funding and you tackle big scientific question. Right. So I would say in China, we can do that too. In many of our funding agencies in China, they can consider that maybe half of the funding reserved for pure basic type of research, another half from funding reserved for more applied research. The foundation support is also very key to the fundamental discoveries because typically foundation support has no string attached. They don't ask anything. They give you research, they trust you, they give you research support. So you can really do totally blue sky type research. So this sort of balance is very important. Okay, so it's from the basic to applied. Now, at the other extreme, we talk about industrial support.
That's right. This
is sort of from big company bringing scientific and technology questions for us to solve. So that's kind of I call it semi-applied, applied research. So I would suggest in China, we can really try to think about coming up with a mechanism that to adopt this sort of balanced portfolio to support both basic and applied research. I would encourage foundation to donate money to researchers in the university to help them to really, for them to focus, to solve big questions. I would encourage also big companies, industry to support our scientists in the universities and the research institute so that they would have also a big portfolio of government support, foundation support, and industrial support.
Right. I understand you have a lot of thoughts about the growing of talents in China and the incorporating of talents from all over the world. Tell us about it.
Recruiting talent is always very important for every country. It's just like in US, it's immigration country. All these best students are going there to pursue their PhD degree. Recently, of course, in China, they invest a lot to recruit sort of young scientists coming back. For example, the Young Southern Talent Program.
Right.
This program is very, very powerful in terms attract those students trained in Europe, trained in United States or outside China. But meantime, we also notice there are some issue arise from these sort of talent recruiting process. When this program started, I think many years ago, the research ecosystem in China is not as good as now. Okay, so back then it's correct. You give some special treatment for those trained outside. Okay, but nowadays, if we look at the sort of research infrastructure, research ecosystem in China versus outside, they are more or less on the same sort of level. At current stage, we really need to think about, okay, we need to treat these young scientists equally. Okay.
On a level playing field.
Yes, we just look at their accomplishment, but not without pay attention to where they're coming from. Okay, as long as they have significant accomplishment, they treat basically in the same way. They have the same level of sort of startup package or benefits. This is very important actually, especially to further sort of encourage our young scientists. Even you don't have to go out. You can get very good education here. You can get very sort of you can do great research in China. It's kind of the self-confidence in the science and the technology sector. Okay, and that's one thing. Another thing is I think recruiting is just first step.
Yeah.
Retention is the second step.
Even more important.
Yeah, it's very important. Very often I notice in China now they focus very much on the recruiting. Okay, because recruiting one, it's basically +1, right? But then normally once they were recruited here, they are basically the retention part is sort of being played down a lot. But I always emphasize this is certainly same thing in Europe or in United States. Recruiting and retention are the two most important things. If you just do recruiting without pay attention to retention, then eventually those talents will disappear again.
Right. Talking about retention, if we could do a little bit further about that, there is a disconnect between the policy still and the qualities of conditions required by the talent. Yeah. And as you may know, systems are not changed overnight. So here's the thing, there's a tension over there. Yep. How do you see that tension?
I think we are doing a good experiment in Shanghai. The efforts I was sort of involved in Shanghai is to build up their physical science school in Shanghai Tech University. All the young people coming in as assistant professor, then we give them sort of enough sort of financial support to run their research. They have total freedom to run their research. Then 5 years later or 6 years later, they can go through the tenure process. Okay, so we'll evaluate based on their accomplishment. Okay, and then during this process, from very beginning, it's called a recruiting. Right. We recruit them, but the next 5-6 years, there's retention issue. You need to be flexible in the retention part, and of course, retention part is about recognize their contribution, right, and also their sort of salary, their benefit. All these things needed to be follow their basically or be commensurate with their contribution.
So what is it to you as a scientist? And do you think that should be to a country, if I could ask you?
Basic science really need patience. Okay, as I said, the discovery very often cannot be planned. So very often it takes 5, 10, 15 years until you crack the problem. So patience is important when we are running the basic type of fundamental research. We do need to give scientists who are willing to tackle these issues time. And I very often said the sort of the profession of being a professor is great because we are founded to do things that we are interested in. Okay, that's a great job, right? Right. Yeah. That's so right. I think every scientist should have this attitude. Okay. Hopefully without worry about all these sort of outside sort of quantitative metrics evaluation. And I think in China we need to encourage this sort of culture. Right. Encourage all the scientists that doing their research as their personal interest.
Let's move on to talk a little bit about the research you're doing. I guess it's probably easier for you in a way because that's something you really enjoy from the very beginning.
That's
and
the
also
thing I think about every day.
thinking about it, I was reading some media stories about you, Professor Yang, and heard that you enjoy watching movies like Martians. You usually use movies to explain to the others the significance of your work. So if I could invite you once again to explain through movies about what exactly you're doing.
Yeah, the movie Martians actually reflects some of my research interest. Okay. My research is more on the sort of developing new materials for energy storage. More specifically, I will call them as artificial photosynthesis.
Is there an easier word for us to remember?
Well, an easy example is the sort of green leaf, right? Green leaf is doing the photosynthesis every day. So the green leaf basically take in carbon dioxide, water, then absorb the sunlight and convert them into oxygen.
That's right.
Like green plants release oxygen to the environment, but meantime they also store the CO2, the carbon, in this another chemicals called carbohydrates, right? So that's the natural photosynthesis happening in nature. What we have been working on in the past little bit over 1 decade or so is coming up with a material system that mimics this process. So right now we have this technology that we have these materials that can really take in carbon dioxide, water, and absorb the sunlight, and then convert them into useful chemicals, gasolines, fuels, polymers, and then also release oxygen back to the environment. And that's why the initial sort of motivation for this research is to fight climate change.
That's right.
Because we all know the carbon dioxide is a greenhouse
So how you're
gas.
doing so far?
Well, doing great. I think we already have the proof of concept. We announced that results 4 years ago. It caused a sensation in the general media and the scientific media. Then in the past couple of years, we slowly improved the stability, efficiency. Now our sort of artificial photosynthesis system is even better than what's happening in nature, compared to the green leaf or green plants.
Mimi are thinking if this could be a success, not only it's going to solve our problems these days, have renewable energy, of course, but also probably help us to explore the outer space, some say.
Yes.
Going to the Mars even,
Yeah.
Professor.
Yeah.
Ever thought about that?
Well, that's exactly what we are doing now. Of course, this process can be used to sort of reduce the CO2, recycle the CO2 on planet Earth.
Yes.
So fight the climate change, global warming, those sort of stuff. If we think about deep space and Mars, that's why it links to the movie Martians, right? If we think about it, we want to move people, live on Mars. You need to worry about many things. Of course, first of all, you need to worry about how to send people over. That's first thing. Second thing, once people are there, you need to think about...
survive.
They have to survive. They need oxygen.
Yes.
Okay, now if you think about on Mars, basically there's no oxygen. But there are plenty of carbon dioxide and nitrogen. Just last year, we opened another NASA center. And this NASA center in Berkeley is to use our artificial photosynthetic technology to convert those carbon dioxide and nitrogen into useful chemicals eventually for the first sort of batch of crew member over on Mars. In the meantime, release oxygen.
Is there some timeline we are looking at, Professor?
The United States has the timeline within 30 years, even though Elon Musk has much shorter sort of plan.
You met him and you ever talked to him?
Not yet. Because very, very often we are talking to NASA scientists at this moment. Yeah.
Yang Peidong, well-known chemist coming from the United States, but originally coming from China, talking about the future and the mechanism for science and technology research. That is all the time we have for today. If you'd like to see more, try to find us World Insight CGTN into your search engine or check out our YouTube channel. You can also follow us on Twitter, Facebook, and Sina Weibo. From me, Tian Wei, and everyone on the World Insight team, thanks for watching and tune in again next time for insights across China and around the world. Good night.